the voltage regulator, which steps down and keeps voltage on certain value, and suppresses unregulated voltage ripple that you can get after smoothing capacitor. On the output of regulator, you'll get perfectly flat voltage waveform, and with that you can power anything you need. You can use fixed voltage regulators or adjustable ones. I showed you an adjustable regulator. It needs two resistors to set the voltage, and you can calculate values of those resistors with formula you can find in datasheet for specific voltage regulator. For lm317 it will look like this, where obviously R1 and R2 are those two resistors, and I adjust is an adjustment pin current. Now if you look in the datasheet, you'll see that this adjustment pin current is really small, 50 microamps typical and 100 microamps maximum, and it's microamps, not milliamps. So to make your life a little bit easier, you can drop less part of the formula because it doesn't have much influence on output voltage anyways. Of course, if you need to precisely calculate fixed output voltage or you are using high values of resistors, you need to keep it. But in case of adjustable power supply and small values of R1, I'd recommend you to make your life a little bit easier. And now when we have really simple formula, we can easily rearrange it to calculate R1 and R2 values. You can transform that formulas a little bit further, but I left it all like that because it's easier to remember. And one more thing, you need to keep R1 value fairly small, somewhere up to 500 ohms. It's because of the minimum load current requirement for lm317. Next, we add an output bypass capacitor. Because without output cap, lm317 could become a pretty good oscillator, which you want to avoid at any costs. Plus, it improves transient response. This capacitor value will depend on capacitor type you want to use. It is recommended to use 1 microfarad solid tantalum cap, because it has low impedance even at high frequencies. But other types of caps will do as well. Instead of tantalum cap, you can use 22 microfarads electrolytic cap or up to 1 microfarad ceramic cap. And if you want to have even higher transient response, you can put even more capacitance on the output. Of course, we live in a perfect world, and there's a lot of high-frequency noise coming from mains. And simplest solution to conquer that noise is to put a few small value decoupling caps. Of course, there's much more techniques to suppress that noise exists, but in this case it would be more than enough to use just a few decoupling caps. Last thing you want to add is some protection for voltage regulator, and bypass capacitor for adjustment pin that will increase ripple rejection capability of the regulator, which is optional. This diode on top protects regulator from shorting out the input while output is connected to battery or big capacitor. Since input smoothing cap has a pretty big value, it causes short circuit for a small period of time when it's completely discharged. And if you will connect battery or charged capacitor to the output while power supply is off and smoothing cap are discharged, the current will flow through the regulator and regulator would end up dead. But if you connect diode between input and output of voltage regulator, current will flow through that diode instead, protecting the regulator. Second diode is needed for basically the same thing, but it protects regulator from discharging this capacitor while output is shorted.